A warm welcome to everyone joining. Thank you for being here. Go ahead and get yourself ready. Grab a notebook, a pencil, or a pen. Whatever you choose to write with is fine. This is math from the void. Math coming at you pretty much out of nowhere. And today we have a quick SAT math style problem. And I'm going to give you about a minute and change, maybe a minute and 15 seconds, a minute and 4 seconds, a minute and 7 seconds, or a minute and 12 seconds approximately. Basically, what I'm challenging you to do is to complete this problem faster than it would take Usain Bolt to run down his street at 75% of his max speed. So you're basically racing Usain Bolt in this problem. No, seriously though, since I'm pretty much reading the problem for you already, go ahead and give the rest of it a proper read. This one is multiple choice, which means you could take a guess, but that's not going to help you in the interest of time. This is a non-calculator problem, which is why I say about how long would it take Usain Bolt to run down the street. Now, I've already pretty much read this for you, but give it a read and then give it a try. And take a minute and 15 seconds, since that's the longest amount of time in all of the answer choices. That would be the longest that it could possibly take him to run down the street. Then when you're ready, unpause the video and you can check out how it was done here. Okay, let's get started. So reading the problem, just full on through, Usain Bolt runs down his street at 40% of his max speed, which is still probably faster than my top speed, to be honest. He can run down the street at 40% of his max speed in 2 minutes. About how long would it take him to run down the street at 75% of his max speed? Now, the interesting thing about this question is we're not given what his max speed is, and we don't need to know the exact velocity. But we're still going to set up the rate equals distance over time equation, and notice that if he's running down the street in both cases, the distance is going to be the same. So we basically have that RT is equal to the distance in both cases. While we don't know his max speed, we can just use 0.40 of whatever his max speed is, that's 40%, times 2 is equal to 0.75, that's 75% of his max speed, times t. So regardless of what his max speed is, we would have that factor on both sides, right? Let's call it v. And so they kind of cancel each other. They don't really matter. Now we can make a proportion by saying t is simply, let's get rid of these decimals. Let's just call it 80 over 75 equals t. And this does reduce down as a fraction. This reduces to 16 over 15, which we know is equals to 1 and 1/15. Be careful. That does not mean that it's 1 minute and 15 seconds, because 1/15 of a minute is definitely not 15 seconds, okay? In fact, let's divide 1 over 15 just to see what this is going to come out to be. So 1 over 15, we know this is like top dog goes in the house, right? Some old school, you'd be able to work this out by hand. You might not want to work this out by hand, but you can totally work this out by hand. That would give us a 10. We drop another 0 down, and we see that it's like 1.066 repeated, right? So another common mistake in this kind of problem is to pick, let's round this up. Let's round this up to 0.07. That means it's 7 seconds. No. It is not 7 seconds, because remember, 1/15 of a minute, if we convert this to seconds, is the same as 60 seconds divided by 15. This is 4. It is only 4 seconds. That is 1/15 of a minute. So it's going to be option B. I don't know if this is true. I don't know how long his street is. I don't know Usain Bolt personally or where he lives even. I just know he's really, really fast. Faster than all of us. So, how did you do on this problem? I hope you were able to finish it faster than Usain Bolt can travel down his street. It should only take about a minute to solve this problem. I think that's enough blab out of me. I'll see you guys next time.